Hello and welcome to this video about conditions and loops. Today we're going to talk about conditions and then we're going to talk about looping. They're both very important when you program. You're going to be using them a lot. So let's just dig into them. Conditions goes back to the atomic types we had talked about, the Boolean variables which could be true or false, and this is basically what we use them for. So what you want to use them for later is when you have some program which can do a lot of stuff, and you want to say, okay, maybe if I get a negative number, then I want to do this, but if I get a positive number, then I want to do this calculations. And this is what you use conditionals for. So here's an example where we divide an integer, define an integer, x equal to 3, and then we sort of say, okay, if, so this is the first conditional statement, if x is less than 2, then do these lines. And sort of the way you tell Python which line to do is by this indentation, the 4 spaces or the tab. So if you write some code down here, then it's going to run whether or not the if statement is true. So you say, okay, if x is less than 2, then execute these lines. And then we have the elif statement, which stands for else if. So if this is not true, but this is true, so if x is larger than 4, then do run these lines of code. Then we have another else if statement, which refers to both of these lines. So if none of these are true, and this is true, then do this. And then we have the else statement, which is basically, okay, if none of the above are true, then do this no matter what. So we see here, because x is equal to 3, then it's larger than 2, but smaller than 4, and larger than 0. So the fourth possibility will come out. We'll have, if it's 1, then it's the first possibility because it's smaller than 2. And then you should note that, as written here, that the third possibility can never really happen, because if x is smaller than 2, then it will also be smaller than if x is smaller than 0, then it will also be smaller than 2. So the first condition will be true, and Python will never sort of check whether this condition is true, because we've already seen that this condition is true, and then Python will just print this and move on. So that's basically how they work. You can write them without all the else statement if you just want to say, okay, if this is true, do this, but otherwise just move along, or only with an else. So you always start with an if statement, but you don't necessarily need the else statement or the else if statement. And sort of here, what Python does is basically it checks whether this is a true or false value by using the bool function, which transfers this into a Boolean type. You can also define the Boolean types earlier as variables, and then use them directly in the if statement. So this is the exact same as before, it's just written a little bit differently, but you can sort of get the same answer now that x is equal to -1. You can also not use the else if statement. It's not really like it looks worse because you have a lot more code and you have to carry around all the previous statements saying, okay, if none of these are true, then do this. But I think it sort of shows the logic of what happens, or what these else statement does. You're basically saying, if not condition 1 and condition 2 is true, then do this. Which is the same as saying here, okay, if this is true, else if this is true. So this must be false before you look at the statement. As I said, sort of Python sort of checks whether the value after the if statement is true or false. And you can put non-Boolean types after the if statement, and then Python will check whether they're true or false, which can sound sort of weird, and sort of depends on the types what that means. For list, basically being true means that there are elements in the list, and being false means that it's an empty list. So if I write here that y is some list with some elements, and then I say if y, then y has some elements. But if I just make an empty list, then Python will not will sort of evaluate y to be false. Yeah, and different types have different behaviors. Sometimes it's useful instead of having to create some true/false statement. But you should also be a bit careful because you have to know what Python defines as false for the type that you're looking at. For integers, then 0 is false and everything else is true. And it's the same with floats. So 0 is false and everything else is true. But floats, which we'll get into in another video, is sort of, sometimes they can be really close to 0 but not be exactly 0. And Python will say that the number is true, but basically, I mean, so here we have a number that's 0 to 100 decimals. So it's, I mean, it would be 0 in my eyes and most people's eyes, but Python evaluates that to be true, even though it should be false if it was a true 0. So you probably shouldn't use if statements with floats. Yeah, so that's the basic of conditions. Now we're going to look at the basics of looping. Basically, when you want to loop, when you have some sort of operation or task that you want to do a lot of times, just with different input, usually. Yeah, so you want to do some calculations on a bunch of numbers, and it's the same calculations, you just want to do it for each number. And it's sort of the straightforward way would be to do it like this, where you sort of, okay, I just want to have a list of numbers, x's, and I want the x's squared. Then I just make a new list, and then I take, okay, the first element squared, the second element squared, third element squared, and so on. And this sort of, it's a lot of code to write, especially you can have loops with hundreds of elements, and it's very error prone. There's an intentional error here. Maybe you can spot it, which sort of shows why it's a bad idea. And also, if I thought, suddenly I realize, actually I don't want the number squared, I want it to the power 3, then I have to edit all the numbers. While if you have it in a loop, then it's much easier, as I'll show you. I'll show you for loops and while loops and list comprehensions. So for loops is sort of when you want to do something for the elements in a list or inside another container. So you sort of, it's a finite loop. You can sort of see it as. So you here you still create an empty list. We want to do the same task as above. We just want to do it in a loop. So we have our x's list, and then we say for each element in x, in the x's list, then we want to append the x squared. And sort of hope this gets us the correct answer. And it's also a bit nicer than this, especially if you suddenly have more elements in the list, then it's sort of, this doesn't update, but this will. Yeah, and sort of this, so for x and x's, what you call this variable, you can define yourself. So sort of Python will understand that. It doesn't have to be a specific name, so it's not like x's and then it has to be x. You sort of define what you call that variable here. Yes. For this specific example, then there's actually an even better way to do it, which is shorter to write and sometimes faster to run. And that's called the list comprehension. Typically, you can use list comprehension if you want to output a list from a list, or another container from another container. And it's a very simple operation you're doing, because you have to do it in a one-liner. So in a for loop, you can write a bunch of more code, like below, and you can multiple lines. But yeah, okay, so this is a list comprehension. So you're basically creating the list as you're in the loop. So you say, I want to make a new x squared list, and I want it to be a list, which you define with square brackets. And then you sort of define the elements by an operation. So you want x squared for each x in the x squared list. And this is the same sort of syntax where you define. So if I write for var, then you get a var in here. You define what you want to call the variable yourself. But that's the syntax of list comprehensions. And this is sort of, you get the exact same answer. It's just a little faster and a little less code. You can also, like a while loop is very similar to a for loop. It's just when you're looping and you don't really know when you don't know how many elements you want to loop over. You just want to loop until something happens. This can be sort of an economics model. It's typically where you're trying to converge to an equilibrium or something, and you say, okay, I want to do this until I found the equilibrium. So you don't know how many tries it will take you, but you have some condition before you say, okay, now I'm done. So what this while loop does is sort of we initialize an empty I squared list, and then we say, okay, we want to start with I being equal to 0, and then we want to run this while loop as long as I is smaller than 6. And then we just append I squared, and then we use the augmentation operator to sort of increment I 1 each time. So first I is 0, and then you get 0 squared. Then you add 1 to I, so I becomes 1. It's still smaller than 6. And you add 1 squared to the list. And then you go and go and go until you hit I is equal to 5. You add that to the list, I squared, 5 squared. And then I becomes 6. And then Python evaluates this while statement and say, okay, now I is not smaller than 6. So we break the while loop. You have to be careful that Python only evaluates the while condition at the end of each loop. So at each iteration, you can also call it. So if you put I plus equal to 1 here, then it doesn't stop until, so it evaluates, it iterates until I is equal to 5, and then it starts here. Plus is 1, so I becomes 6. It adds 6 squared, and then it evaluates, okay, well, I is actually equal to 6 now, so it's not smaller than 6 anymore. So you can see that 6 squared also becomes part of the list, while if we have it below, then it doesn't, because Python only evaluates the while condition at the end of each iteration, or at the start. That's sort of the same. Another way to go about it is using a range. Range is really nifty inbuilt function that's just sort of basic counts. If you just input one argument, then it counts from 0 and then integer wise upwards to that number minus 1 because of the indexing. So if we say for x in range of 6, then you count from 0. So I printed each element for each iteration, and then you count up to 5 because it's sort of you count up to 1 minus the number you write in the range. And again we make a list of x squared. Range is sort of really useful, and you get to learn it better later. But one other thing, if you write one number, then it's sort of from 0 to that number. But you can also use it with this sort of syntax where you write where you want to start and where you want to end, and how many numbers you want to add each time. So here you're adding one number each time. If you write 3 as the last argument, then you're adding 3 each time. So here I say I want to make a loop where I start at 3, I end at 15 minus 1, and I add 3 each time. So we start at 3, 6, 9, and then we stop at 12. If I set 16 here, then we'd stop at 15. And 17 doesn't do anything because there's not, you sort of have to add 3 each time. You can make even more complex loops. Sort of loops can get really messy. They're really good, but they can also quickly get messy. So these are some of the tips for making them less messy when you're looping a lot. So there's I'll just go through them. There's an inbuilt function called enumerate, which enumerates the numbers of the elements in the list that you're looping over. The indexes will sort of also be in your you'll sort of know what they are at each iteration. So here, when you call enumerate, then you get two outputs that you sort of need to call something. So you get I, which can be any name, but here I call it I, which is the index, and then you say comma, and then what the actual element in the list. So here we can see, okay, if we loop over this X list, the first index is 0, because it's always 0. And the second index 2, 1, 2, 3. While the X is squared. Here it's a multiplication, so you have 10 times 0, 0, 25 times 1 is 25, 31 times 2 is 62, and so on. Another thing you can do in loop is using continue and break, which are sort of statements you can use inside of loop, which does two different things. So the continue say, okay, I still want to be in the loop, but I don't want to do anything more in this iteration. So you sort of go back to the beginning of the loop and then you choose the next element. While break stops the loop entirely. So what we have here, the X list is here we're just making a list from the range function. So it's just a list from 0 to 9, basically. It's just an easier way to make it. Okay, and then we say for each index and element in the X list, do this loop. So we check if the index is equal to 1, and if we do that, then we don't append, because we're sort of continuing to the next iteration where the index becomes 2. And then the next else if statement is, okay, is the index equal to 4? And if it's equal to 4, then we stop the loop entirely. So what happens is just that at index 0, then we get x squared, which is just 0 squared. So we get 0. At index 1, then we skip, so there's no 1 squared. And then you continue, then you get 2 squared is actually here, and 3 squared is actually here. But then when the index becomes 4, then we break the loop, so there are no more elements. So if we didn't have this statement, then the list becomes much longer, because we don't break the loop. So this was a lot about looping. I have other stuff to show you, but first I have a little task which sort of uses some of these skills we have just looked at with loops. So the task is to create a list with the 10 first positive uneven numbers. So it's just the first 10 numbers counting from 0 and upwards which are uneven. And there's multiple different ways to do them. And the most important thing with programming is just do them the way you think is the most straightforward, and then you can write it prettier and faster later. So yeah, if you want to pause the video and try to do that, you should pause the video and try to do that, and you can pause now, and then I'll show you afterwards. Yeah, hopefully now you've given it a go and maybe created some code that maybe works, maybe doesn't work. And I'll show you sort of 3 different ways that you can do this. I call this the long way, which is sort of the most, I'm not even sure it's straightforward, but it utilizes a lot of these things we have learned and sort of becomes a lot of code, but it gives the right answer. So we start at 1, the first positive number. and then we have an empty list, which will be our output. And then I make a while loop, which is just as long as this list is not does not have length of 10, because we want 10 numbers, then keep doing this. And what I'm basically doing is I'm using the modus operator, which returns the remainder after division. So if you have a number and you use modus and then 2, then it's sort of, if that is 0, then it's an even number, and if it's not, then it's an uneven number. So what I do is basically, okay, I check this condition, and if this is true, then I do nothing. And if it is not true, then I know it's an uneven number, and I append it to the list. Yeah, and then I iterate or I add 1 to I each time, so I count upwards a single number at a time. And this sort of it gives the correct answer. A lot of uneven numbers, or 10 uneven numbers. Yeah, but there's a better way to do this, of course. Much faster way is just to use the range function and say I want numbers from 1 to 21, but I only want every second number. And if I start from 2, all those numbers will be uneven. Yeah, and then it's to 21 because I only want 10 numbers, but you're only taking every second number. And then there's sort of a mathy way, which is just to count the numbers from 1 to 10, and then multiply them with 2, so it's an even number, but then you just subtract 1 to get the uneven numbers. Yeah, it doesn't matter which way you did it. I think I would prefer this way because it's a one-liner, but it's sort of the most important way when programming is to write code that does what you want it to do, not how it looks. It's important, but it's secondary to actually having working code. Yeah, another thing you can do is you can use the zip function, which the names comes from sort of a zipper, like a jacket, that you're zipping together 2 lists and using both elements at the same time. So here we have a list of Roman numerals from 1 to 3 and ABC. And then we just print the elements side by side using this zip function. Yeah, and the output is sort of the first value is here, that corresponds to x, and j corresponds to the second value in the zip. And then zipping is not the same as nesting. So nesting is when you put a loop inside a loop, and it's similar, but when you use nesting, then you're saying for each I and x, also do this loop. So you're getting a lot more iterations than zipping, because you're saying, okay, for the first element in x, the 1, then I want to print 1 plus a, 1 plus b, 1 plus c. So here in the first you're getting three iterations, because you have 3 elements in both lists, while here you're getting 9 iterations because you have 3 elements in this list and 3 elements in this list, and you sort of multiply them together. So nested loops can get like really heavy if you have a lot of elements in both your list, and you can have nested loops inside nested loops. When you do that, sort of, especially when you have nested loops inside nested loops, it's probably nicer to use itertools, which is just a package from a Python package, which sort of allows you to write these things out in a nicer way. So here you can use the product, which sort of creates all the possible combinations between x and y, and just creates them in one loop. So it outputs the exact same as here. It's just a little bit nicer code. Yeah. And then we have dictionaries, which you can also loop through. You can loop through almost all containers. And dictionaries, you sort of loop through the keys or the values of the dictionary, or both at the same time. So if you loop through both at the same time, then you have to use items. and then it's the key first and the value second. And you can also check, so you have another if condition or conditional, which is you can check if the key is inside a dictionary, and then you can do something. And this is typically faster than a loop over all the. Yeah, it's not typically. It is faster than the loop over all the variables. And then you saw A is actually inside the dictionary, which defines like this, A, B, C, and lines. And then Python will print this, and you can also do it for a value, a key that is not inside the dictionary, and then Python just prints that. And it's sort of, the reason you want to know this is because it's quicker than looping through all the elements and checking. So the central concepts in this video was conditionals, the if, else if, and else statements, the loops, the for loops, the while loops, using the range, enumerate, and using the continue and break statements, and using the zip function. Then you have list comprehensions for when you are doing a loop, but you want to do it, it's sort of simple operation you're doing, and you can write in one line. And then there's the function itertools. Thank you for watching.